Dear students, welcome to this presentation. So in this presentation, I am going to explain unit number 1, session number 1, that is the IC logic families of digital electronics subject for third semester electrical and electronics engineering students. The unit number 1, so if you see the course outcome, so it goes like this. Understand the basics of IC logic families. So once the unit 1 completes, the student should be able to answer what do you mean by IC. So what are the different logic families, the comparison between the different logic families, advantages of ICs, why the ICs are invented. So like some of these questions, so you can able to answer after completion of the unit number 1. So now we'll move on to the content. So first we'll see the introduction. Engineers classify electronic circuits as being either analog or digital in nature. So mainly we can classify the electronic circuits as analog or digital. So based on the characteristics. So what do you mean by analog or analog circuits? An analog quantity is one having continuous values. Most of the things that occur in nature are in analog form. For example, the air temperature changes over a continuous range of values. Same way, speech, video, light intensity, heartbeat rate, etc. So you observe this. So these are all available in nature. These are the natural signals we are getting. So if you observe all these signals, so we are having a continuous values. So there is no discontinuation in the signals. So we are getting the continuous signals. So that is a main basic of analog. Analog is nothing but it is a continuous signals. Okay. So for example, you all might have seen the sine wave. So sine wave is best example for the analog quantities. So it is a continuous signal. This is x-axis. We are plotting the time, and the y-axis the quantity. So we can able to have a continuous signals. That is the analog. But the most convenient way to represent and transmit information electronically is digital, because the digital domain being is so dominant in electronics, they are trying to push as much as possible in digital domain and have as little as possible in analog. So, but today technology has improved so much that it is easier to do in digital as digital cost is becoming lower and lower. So ನೀವೆಲ್ಲ ಇವತ್ತು ಅಬ್ಸರ್ವ್ ಮಾಡಿರ್ಬೋದು. ಸೊ ಎವ್ರಿಥಿಂಗ್ ಈಸ್ ಡಿಜಿಟಲ್. ಸೊ ನೀವು ಮನೆಯಲ್ಲಿ ಅಪ್ಲಯನ್ಸಸ್ಗಳಿಂದ ಇರ್ಬೋದು, ನಿಮ್ಮ ಮೊಬೈಲ್, ಕೈಗೆ ರಿಸ್ಟ್ ವಾಚ್, ಸೊ ಈಗ ಸ್ಮಾರ್ಟ್ ವಾಚಸ್ಗಳು ಬಂದಿದೆ. ಸೊ ಎವ್ರಿಥಿಂಗ್ ಈಸ್ ನೌ ಡಿಜಿಟಲೈಸ್ಡ್. ದ ವರ್ಲ್ಡ್ ಇಟ್ ಸೆಲ್ಫ್ ಈಸ್ ಡಿಜಿಟಲೈಸ್ಡ್. ಸೊ ಇಂಟರ್ನೆಟ್, computers, so many things, everything will be in the digitalized. Okay. So that is the importance of digital electronics. So nowadays, compared to the analog, so digital is ruling the world. So most of the devices, as I already told, they are digital systems. So these are become the part and parcel of our day-to-day life. Okay. So one of the main cause of this revolution is the advent of integrated circuits. So why that digital electronics so much is revolutionized? It is because of a integrated circuits, that is ICs. Okay. So it is a small component, so which is made all these digital revolutions in the world. So this is a basic block for the digital electronics. So IC. So in the next sessions, you can able to see what is the definition of ICs, what are the advantages of ICs. So in the coming sessions, so you may see, you may observe that. So first we'll see the IC logic family. So what do you mean by IC logic family? So The definitions goes like this. IC logic family is a group of compatible devices with the same logic levels and supply voltages for performing the various logic functions. Okay, I will repeat. IC logic family is a group of compatible devices with the same logic levels and supply voltages for performing the various logic functions. Okay, so if you take a family, general example, so family consists of a members of a own blood relations. Okay. So similarly, IC logic family is also a group of compatible devices. Devices is nothing but ICs. So compatible ICs with the same logic levels. The characteristics will be same and the supply voltage will also be same. So then only we can able to interface those ICs. Okay. So that is and they will be compatible. Okay, so after that they will perform the various logic functions. Okay, so what is the main thing? The electrical characteristics of the IC, like voltage range, speed of response, power dissipation, noise margin, fanning, fan out, etc. will be identical. Okay, so if you take the different ICs, okay, so these characteristics should be same for all the ICs. Then only we will categorize them as the same families. Okay. So this is about the IC logic families. So these are basically ICs which are compatible. We can group into the one family. Okay. So this is about the IC logic family. So same thing, different ICs belongs to the same logic families will be compatible with each other. Okay. So some of the examples of IC logic families are TTL, that is transistor logic, CMOS, okay, that is, and ECL, emitter coupled logic, and CMOS is complementary metal oxide semiconductor. Okay. So these three are the examples for the IC logic family. So in the coming sessions, we will be able to go through in detail the TTL characteristics, CMOS characteristics, ECL characteristic, and the comparison of these three families. That will be detailed study will be there in the coming sessions. Okay. So for time being, so just know these are the three examples of IC logic family. So next we will move on to the next slide. So we'll see the some of the definitions. Okay, so our characteristics of the ICs. So what do you mean by exactly the definitions of some of the terms? Okay, so first we'll see the threshold voltage. Okay, the threshold voltage, the definitions goes like this: the minimum input voltage at which a logic gate output changes from one state to another state. Okay, the state may be 1 to 0 or 0 to 1 or true to false or false to true. Okay, so threshold voltage is nothing but a minimum input voltage, okay, which is applied at the input of the gate, which causes the output to be present at the output side. Okay, and the output will be changes from false to true or true to false or 1 to 0 or 0 to 1. So threshold voltage is basically the minimum voltage which triggers the output. Okay, so that is nothing but the threshold voltage. Okay, so we'll see the threshold voltage for different families in the next slide. So just you can observe here. So this is the 0. So 0 is the low volt state and 5 is the high state. Okay, that is nothing but 1 and 0. So in between there are so many voltages levels they have shown. Okay, so first we see the CMOS. Okay, so CMOS, as I already told the example of logic family, IC logic family. So we just observe the CMOS here. In this, you can see the threshold voltage. So this is VT. So VT is nothing but the threshold voltage. So they will mention the VT for CMOS is 2.5 volts. Okay. So this is the VIL is the minimum input, low input voltage, and this is the threshold voltage, and this is the minimum IH. IH you can see here, input high level voltage. Okay, the input side. So this is the high voltage is 3.7 volts. So this is the minimum voltage. This is the minimum input voltage which causes the output to change the state. So this you can observe here. So this is a VIH. VIH is the input high level voltage. So this is the input high level voltage is for CMOS is 3.7 volts, and this is the minimum input voltage. Okay. So this minimum input voltage, we can call it as a threshold voltage. So that value will be different for the different families. For the CMOS, it will be 2.5 volts. And if you observe here for TTL or CMOS, it is 1.5 volts. Okay. And similarly for TTL, it is 1.5 volts. Similarly for ETL, it is 1.5 volts. And there will be different threshold voltages for different families. Okay. So this is the concept of threshold voltage. Okay. So this threshold voltage is the minimum input voltage. So that is output change, state change help input voltage, minimum input voltage. So that is this is the arrow mark you will not bother. So arrow mark is 2.5 volt. So illivargu ಏನು ಬರುತ್ತಲ್ಲ ಅದು maximum input voltage. So illivargu ನಮಗೆ input voltage ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಬಹುದು. ಇಲ್ಲಿಂದ ಮೇಲ್ಗಡೆ ನಮಗೆ output voltage ಬರುತ್ತೆ. Okay. So ಈ ಪಾಯಿಂಟ್ ನಮಗೆ threshold voltage ಅಂತ ಕರೀತೀವಿ. Okay. So just we'll move on to the next definition. So next definition is propagation delay. Okay. Just we'll see the definition. So the definitions goes like this. It is defined as the time delay between the application of level change at input and change of state at the output. Okay. So it is defined as the time delay between the application of level change at input and change of state at the output. Okay. So when you apply the input at the input side, okay, so the output will change. The delay, the time delay between the application of your input pulse and obtaining the output, that is called the propagation delay. Okay. The speed of the digital circuit is specified in terms of propagation delay. So for any digital circuits, okay, so if you want to calculate the speed, then you will go for the propagation delay. So propagation delay ಮೇಲೆ ನಾವು speed of the digital circuits ಅನ್ನು decide ಮಾಡಬಹುದು. Okay. So propagation delay ನಮಗೆ ಜಾಸ್ತಿ ಇತ್ತು ಅಂತಂದ್ರೆ ಅದು ಸ್ಲೋ ಆಗಿ ವರ್ಕ್ ಆಗುತ್ತೆ. So propagation delay ಕಮ್ಮಿ ಇತ್ತು ಅಂತಂದ್ರೆ circuit will be fast. Okay. So time duration ಕಮ್ಮಿ ಇದ್ರೆ circuit fast ಆಗಿ ವರ್ಕ್ ಆಗುತ್ತೆ. So ನಮಗೆ ಅಡ್ವಾಂಟೇಜಸ್ ಏನು, propagation delay should be less. So propagation delay ಕಮ್ಮಿ ಇರಬೇಕು, so that ನಮಗೆ ಫಾಸ್ಟ್ ಆಗಿ ಔಟ್ಪುಟ್ಸ್ ಬರುತ್ತೆ, ಸರ್ಕ್ಯೂಟ್ ಕೂಡ ಫಾಸ್ಟ್ ಆಗಿ ವರ್ಕೌಟ್ ಆಗುತ್ತೆ. Okay. So that is the concept of propagation delay. So this propagation delay, it is measured in microseconds or maybe nanoseconds or maybe picoseconds based on the requirements. So you can just observe here the figure. So this is the input pulse and this is the output pulse. Okay. And this is the one simple gate is shown here, NOT gate, one input, NOT gate. VIN is the input and Vout is the output. Okay. So you observe here, this is the input pulse. It is going from 0 to 1. Okay. So this is 0 state and this is 1 state, high state. So from low to high at the 50% of the duty cycle, this point. Okay. So just see here, this is the output pulse. So output pulse is going from 1 to 0. There is a complement of input. So here it is 0 and here it is 1. Okay. So this is the application of pulse. Here it is going from 0 to high. So at the same time your output is going from 1 to 0. So if you observe here, so this band, so this is the propagation delay. Okay. So we are applying the input and we are getting the output. So similarly, the pulse going from 1 to 0 again. Okay. So 1 to 0. So your output is going from 0 to 1. Okay. So 0 to 1. And this is the band you can see here. So this is again the propagation delay. Okay. So there are two times it is happening, from at the starting point and at the ending point. So rising edge and falling edge, we can call it as. Okay. So the propagation delay, we can tell it as, this is the formula TPHL plus TPLH divided by 2. Okay. At high to low and low to high. Pulse at high to low and pulse at low to high divided by 2. So we are taking the average of these two, and that will be your propagation delay. Okay. So this is a definition of propagation delay. So main concept is propagation delay should be less so that it will be advantageous. So your circuits will be works faster. So next definition is power dissipation. Okay, the definition goes like this: the power dissipation for a logic family is the power consumption per gate, and it is the product of supply voltage and average current. Okay, so for any circuit or for any gate, okay, so it has to consume power. So without power, so nothing will run. Okay, so here also the gates will consume the power because they will draw the voltage and they will draw the current. Okay, the formula is nothing but same. Whatever will take the formula for the calculation of power. Power is nothing but the product of voltage into current. So here also there is a product of voltage into current. So but here it is a VCC, that is a supply voltage, and it's the average current. Okay, so average current. So why you have taken the average current for this? So that will be explained in the next slide. So we will see why the average current is taken for the calculation of this power dissipation. Okay, so again I'm repeating, the power dissipation for a logic family is the power consumption per gate, and it is a product of supply voltage and average current. So if you multiply these two, you will get the power consumption. Okay, so that is nothing but your power dissipation. So you'll see the formula for this power dissipation, that is Pn is equal to VCC into I average divided by N. Okay, so where N is the number of gates present in the IC. Okay, so on IC there may be a several number of gates present. Okay, so that's why this formula divided by N, and I average, as I already told, so it is ICCH plus ICCL. Okay, so because there are two states, high state and low state. So ICCH and ICCL are the current drawn at high state and low state respectively. So because both the currents will not be the same, the current drawn in the high state will be different and the current drawn in the low state will be different. So that's why we are taking the average of high state and low state. Okay, so that's the formula, that is VCC into I average. It gives the power, where N is the number of gates. We will divide the product by the N number of gates. Okay, so usually power will be measured in watts. Watt is the unit of power. So but here the power consumption is in the order of very less few watts. So that's why we will express in milliwatts. So milliwatts will be sufficient to measure the power dissipation. So this is about the power dissipation definition, and what is the formula and what is the unit for finding out the power dissipation. So this ends the session number 1. So session number 1 is a simple one. So it talks about the IC logic families. So what do you mean by IC logic families? So it is nothing but a group of computable devices which are having the same supply voltage, same characteristics. So we can group in a one family. So that is nothing but the IC logic families. So as I already told, the examples for the IC logic families are TTL, transistor logic, CMOS, and ECL, emitter coupled logic. So these are the examples of IC logic families. So that will be the IC logic families. So the coming to the characteristics or definitions. So you have seen the 3 definitions. So 3 definitions, what you have seen. Okay. The first definition is threshold voltage. So what do you mean by threshold voltage? So that is a minimum input voltage at which a logic gate output changes from one state to another state. So input anna minimum input voltage and apply madadaga now output voltage we will get, then the state will be changed from the 0 to 1 or 1 to 0 or 2 to false or false to 2. That is the threshold voltage. So that's a different threshold voltage will be there for different families, as I already explained. So propagation delay again is another characteristics where we can able to find out the time delay between the application of input and getting the output. Okay, so that is nothing but your propagation delay. So speed of the digital circuit is specified in terms of propagation delay. So next one is the power dissipation. The power dissipation is nothing but a power consumption per gate, and it will be the product of supply voltage and average current. So I already explained why average current has to be taken. So since there are the two states, we are averaging it the current, and it is expressed in milliwatts. So this is about the three definitions and IC logic families for the unit number 1. So we'll see some of the multi-choice questions for the unit number 1 and session number 1. Okay. So we'll see the question number 1. The question number 1, power dissipation usually expressed in option A, megawatt, option B, milliwatt, option C, watt, and option D, kilowatt. So which unit we will measure the, or we will express the power dissipation? Is that option A, or option B, or option C, or option D? So we know power is measured in watts, but ICs or gates consumes very less power. So the answer should be S, that is should be milliwatt. Okay, so we'll express in the milliwatt, option B. So we'll see the question number 2. The minimum input voltage at which a logic gate output changes from one state to another state is dash. It's option A is threshold voltage, option B is input voltage, option C is output voltage, and D is the nominal voltage. So these are the 4 options. So what is the right answer for this question? So the minimum input voltage at which a logic gate output changes from one state to another state. So which voltage will cause this state change? Is it option A, threshold voltage, or option B, input voltage, or option C, output voltage, or option D, nominal voltage? Okay. So just think which may be the right answer. Yes, that is threshold voltage. So this is the minimum input voltage at which a logic gate output changes from one state to another state. So question number 3, power dissipation per gate is the product of supply voltage and dash. The options are option A, current, option B, frequency, option C, time, and option D is speed. So which is the right answer for this question number 3, power dissipation. So usually it is a product of supply voltage and dash. Which one will be the right answer? Guess. Yes. That is option A. It is current. It is supply voltage and current. Okay. So these are some of the questions, multiple choice questions relating to the session number 1. So also you may get the questions in the examination, like the definitions I already explained. So they will ask for the definition of the characteristics of the ICs. And these are the some of the books, good books you can refer for more information. And you can also go through the Wikipedia, so you can get all the information whatever you want. Okay. Thank you for watching this presentations. Thank you.